Welcome back, guys. In our last episode, we began speaking about the language of chemistry, how to talk like a chemist. How do we take elements and combine them together to form compounds? Remember, we said the type of compound we form depends on the type of intramolecular bonds that hold them together. And there are two types that we began to talk about. Those are covalent bonds, which form molecules between two nonmetals, or we talked about the Ionic bonds, which form salts, which were between a metal and hydrogen and a nonmetal. And we learned how to do simple binary ionic compounds. That means a compound made up of a metal combined with a nonmetal. We learned how to write them using the crisscross method and how to name them. Well, today we're going to take it one step further and talk about polyatomic ions and how to write chemical formulas with them and how to name them. Great thing is you're only learning one new step. Okay, it's a really important step, but it's pretty simple. And these new polyatomic ions we're bringing in, don't worry, you don't have to memorize them. I'm going to give you a cheat sheet for them to make it easy. So let's go ahead and talk about polyatomic ions. Polyatomic ions, if we look at the prefix poly, what's that mean? Well, poly means many, okay? So a polyatomic ion is an ion that consists of more than one atom that are bonded together, okay? So we have a bunch of atoms stuck together, but that group of atoms carries a single charge, okay? So that whole 2, 3, whatever, however many elements are bonded together, they have a charge. They act just like a single ion, like you learned about last episode, okay? They behave as a single group. Okay, let's show some examples here. Hydroxide, OH minus 1. Oxygen and hydrogen bond together, and overall they carry a -1 charge. Carbonate, CO3. Overall it has a -2 charge. And ammonia, NH4 plus 1. This is our only positive polyatomic that we'll need to know, by the way. Okay, so let's look at how we can use these. Okay, first of all, big thing for you to know. You do not have to memorize these polyatomic ions. Either I already gave you a polyatomic sheet or I'm going to give you one. Okay, you're going to use this polyatomic sheet when you do it. Okay, don't lose this. Okay, I made it a bright color for you so you wouldn't lose it. Save it for second semester. You're going to need it second semester as well. If you lose it, I'm not giving you another one. Well, how do you get another one? Go to the website, print it off from there. It's on there, but it's not cool and yellow and bright or whatever color I make it. So please don't lose this. Keep it with your good periodic table. Okay, we're going to provide you a copy of this on the test. Okay, to be on the back of your periodic table. So you're never going to have to memorize these. But since I give them to you, you better spell them right, because the spelling's right there on the sheet. And here's what that polyatomic sheet will look like. Notice it's broken down by charge. We got the -1s, the 2 minuses, -2, the 3 minuses, and then we have one down here, only one positive polyatomic ion. Okay, and there are more polyatomics out there than these, but these are the ones we're commonly going to use. So if you don't have a copy of this, I'll get you a copy of this next class. So let's talk about writing formulas of polyatomics. It's real simple. You're doing what you already know how to do. It's simply the crisscross method, where we're crisscrossing the charges. Okay, let's do magnesium sulfate. Magnesium has a +2 charge. Sulfate, if we were looking on the poly sheet, is an SO4 -2. Okay, so to write the formula for magnesium and sulfate, we do the crisscross, right, and drop the charges. We get MgSO4. Now notice we didn't bring the 2's down here. Why not? Well, they both have a +2, and just like with binaries, if the charges are equal, we just ignore them because we want that lowest common denominator, what we call the empirical formula on here. So both 2's cancel each other out, and we just write MgSO4. Pretty simple. Okay, here is the one catch though. If you have more than one polyatomic ion, what I mean by this, when you're doing your crisscross method, okay, if you're dropping down a number to the polyatomic that's a 2, 3, or 4, okay, we must put your polyatomic in a parentheses and then put the subscript outside that parentheses, kind of like we see here. Whatever we were doing here, maybe aluminum, Al minus 3. Brought the 3 down, okay, and we put the 3 outside the parentheses. If it's a 1, we don't have to worry about this. This is very, very important. I'll tell you what, if you put all your parentheses, for right now, if you put all your polyatomics in parentheses, I'm not going to mark off if it's a 1 and you have parentheses and you shouldn't, okay? But if you need parentheses and you don't use them, I definitely will mark off. Let's look at this one, calcium hydroxide. Calcium has a +2 charge, hydroxide is a -1. Okay, so there's drop the 2 down this way, you're going to drop the 1 down this way. Okay, when we write them, we don't want to write it this way, okay? That's incorrect. Okay, we want to write it this way. Since we have a 2 or greater coming down, we put our hydroxide in parentheses and separate it. Here's why. Do the parentheses matter? It does. Let's look at our 2 versions we wrote these calcium hydroxide. Here's the correct version. Okay, if we analyze this as far as the number of elements, what we see is there's 1 calcium because there's no subscript down here, so we call it a 1. This 2 gets distributed to everything inside the parentheses. So we got 2 oxygens and 2 hydrogens. Now, if we don't put those parentheses in, look at, we have 1 calcium, 1 oxygen, and 2 hydrogens. These are not the same compound. They have different ratios of atoms. Think about like carbon dioxide, CO2, and carbon monoxide. Yes, I know they're molecules, not salts, but look, right? Carbon dioxide is something we breathe in, breathe out all the time. Carbon monoxide, if we breathe it in, it's going to kill us. Okay, so it's very important. A single difference between elements or number of atoms of each element is very important. So make sure you use parentheses. Okay, naming these, real simple. Follows the same rules as we did for the binary ionics. Okay. For what we call the monatomics. When we put 2 monatomics together, we got a binary. Okay. So the name of the cation. Remember the name of the cation? We take the name of the cation, drop the word ion. Okay. So basically, it's just the name of the element. And then the name anion. Okay. It's the name of the anion. Okay. Well, that's going to be what your poly is, or if it's not a poly, if it's monatomic, we have the IDE ending. Okay. Spelling counts. If you misspell one of the polyatomics because you're too lazy to copy it off the sheet correctly, I will mark it wrong. Okay, so let's look at a couple examples. Okay, copy it off the poly sheet. Couple examples. KBr. Well, first thing I should look at, and I see, whoa, I have 2 elements. There's no way this can be a poly, because poly I need at least 3 elements. So this is just a binary. So we use our rules we learned last time. Potassium bromide. We take our anion ending and do ide. How about this one? What do you think this will be? Aluminum plus chlorine makes it ide, so aluminum chloride. Simple. Let's try one with a poly. Magnesium, Mg, NO3 is nitrate. Notice Mg must have a +2 charge because it came down here. So this is going to be magnesium nitrate. Okay, once you have the chemical form, name them is really simple. You just got to copy off the sheet. How about this one? K, MnO4. This is an interesting one. This is potassium permanganate. MnO4 is permanganate. Spell it right off the chart. Pretty simple. And this is, I think, doing the names for your polys are actually easier than doing the binary because you have the names to copy down. Okay, I want you to do some practice here. I want you to copy these 4 down. Once you get them, pause the video now, copy them down. Once you've got them written down, come back and hit play because I'm going to give you the poly sheet. Okay, now that you've wrote those 4 down, here is the poly sheet. Pause this, use this poly sheet to write the chemical formulas for those 4. When you're done, come back and we will check them. Alright, let's see how you did. First one, calcium sulfate. Calcium is a +2 charge, sulfate is a -2. When you crisscross, the 2's cancel each other out, and we're left with CaSO4. How about this one, sodium hydroxide? Sodium, Na, is a +1, hydroxide is a -1, so when you crisscross, the 1's cancel. Now guys, hydroxide is a tricky one, along with cyanide, Cn. Both hydroxide and cyanide, people seem to forget when they're dropping their parentheses, or dropping their 2, 3, or 4 charge, they forget to use parentheses with them. So put a little asterisk next to those 2 on your poly sheet when you get it so you don't forget. Okay, beryllium acetate. Okay, beryllium has a +2 charge, I believe, And acetate has a -1, so when we bring the 2 down from beryllium, we got to put it outside the parentheses. So we have 2 acetates, not 22 oxygen. So hopefully you did not forget it. Alright, then there's our final one, ammonium sulfate. Ammonium is NH4 plus 1. It's our only positive poly, and sulfate is SO4. So when we crisscross, we got to bring the 2 down from sulfate to ammonia, and don't forget to put the 2 outside the parentheses. Very important. Okay, quick information for you. Sometimes you're going to see something called bisulfate or hydrogen sulfate. I believe your poly sheet will call them hydrogen sulfate. Know that the prefix bi and hydrogen mean the same thing, whether we're talking about bisulfate or bicarbonate or whatever. It means the same as hydrogen. You need to know that because we use them interchangeably. I'm pretty sure it uses the term hydrogen on your poly sheet. Maybe beside those you also want to write the prefix bi. Okay, the next part here is a little FYI for you. If we look at the endings, ate and ite, look at sulfate and sulfite. What do you notice? Well, ite, in the ite one, there's 1 less oxygen than there is in the ate one. Same with nitrate and nitrite. Okay, there's different, doesn't necessarily mean a fixed number, but it means the ites are 1 less oxygen than the ates. Okay, if we have a per sulfate, it means we'd have 1 more than 8. So rather than being SO4, it'd be SO5. If we have a hyposulfite, it means it's going to be 2 oxygens less than 8. So rather than SO4, it's going to be SO2. Now you do not need to memorize this. This is just to help you as you go through along. Try to figure out what these are, move through them a little bit, and understand some of the nomenclature. You do not need to have these memorized. You can find this all on the chart without knowing ates and ites. But I would make sure that you know that bi and hydrogen prefix mean the same thing. Okay, so today we added on to our naming of salts by adding polyatomic ions. Writing the formulas, it's the same way. We use the crisscross method. The only thing is you got to make sure if when we're crossing, we're dropping a number 2, 3, or 4 to that polyatomic, we put that polyatomic in parentheses. It does matter. Now, for right now, if you put parentheses around every polyatomic, even the ones, that's fine with me. I'm not going to mark them wrong for having parentheses when you don't need them, in case of a 1. But if you don't have them and you need them, they will be wrong. So make sure you know that. Naming, like I said, is even easier than with a binary because you got the polyatomic cheat sheet. Okay, spell them correctly. Alright, on the next episode, we are going to talk about our final type of salts, and that's with ions that have more than 1 charge, what we call variable charge. But until then, guys, if you're not understanding this, as always, please come and see me. It's your responsibility to check in with me if you need help. So I'll see you in class. Take care.